Let's look how you can use the additional settings to tweak your environment. So let's go to our network policy and under additional settings. So in here, one of the most common things that you probably want to change is a DNS server. So what we'll do is, instead of using the default publicly accessible DNS servers that Extreme provides, we'll use a private DNS server, and we'll call this private DNS. And the purpose of additional settings is these are network-wide settings that we want to have available for all the devices that are using this network policy. And these are common resources like DNS servers, NTP servers, SNMP, syslog servers. However, you can use location or cloud config groups in order to assign different ones depending on the location of the device. So in here we'll apply a new DNS server and add 10.5.1.10 and make it the primary one and use the other two as a backup. So now we are telling all of our infrastructure devices to use this particular DNS server. So let's save this. We could do a similar thing for NTP servers. Again, we're using external ones. You may want to configure just the same way as we did for the DNS. You might configure an internal one. You can activate an SNMP server for the access points to send SNMP traps to, similar to with a syslog server. And then down here, you have things like, do you want to log ACSP events, so channel change, power change events? Do you want to activate a Bonjour gateway service if you're using MDNS and you want to MDNS to traverse between different VLANs? This is how you can enable it. And the Extreme wireless cloud device can act as a Bonjour gateway to make sure that the MDNS discovery does work between two VLANs. Device credentials are the credentials used to be able to SSH into an individual device. All Extreme wireless cloud devices do have a full-blown CLI, so you can SSH into them if you want to. Time zones. Another thing you can apply during different classifications, so depending on where the devices are, you can apply a different time zone to them. This is where you can change the Hive key or the encryption key used to encrypt the control plane traffic between the access point. Changing the management VLAN and native VLAN. So what we will do in here is we will change the management VLAN of the AP from 1 to 2, because using the default VLAN as management is usually not the best practice. So we'll create another VLAN. And we will say this is VLAN number 2. Again, you can apply a different VLAN based on device classification. We only have one building, one floor, so we won't do that. But the same way as we apply different VLANs depending on where the user is located, we could do the same thing over here. Okay, so we'll be overriding, and we will use VLAN 1 as a native VLAN. So let's save that. And let's deploy the policy to the AP. Extreme Cloud IQ is used to manage complex environments, either for centrally deployed or highly distributed networks. Now, where you're in a highly distributed network environment, you're sitting in location A, say that location is New York, and you're pushing out configuration, say, to Sydney, Australia. Now, what happens if the configuration that you're pushing out causes disruption in connectivity? As an example, you make a mistake in the management VLAN setting. You push out the incorrect management VLAN to all of your access points in Sydney, and the result is going to be, because that VLAN doesn't exist there, all the access points lose connectivity. This is usually a time for panic, because you're sitting in New York, the access points in Sydney have just gone offline. What do you do? Well, there's a mechanism built into Extreme Wireless Cloud APs, and that mechanism is called Configuration Rollback Timer, and it's enabled by default on all the access points. You can disable it if you want to, but it's actually a very useful tool when you're managing remote deployments. And the way it works is, the access point always assess whether they're able to connect to the Extreme Cloud IQ cloud using the CapWeb protocol. If they cannot do that after a configuration has been pushed, then they will revert all the changes of configuration and revert back to the previous known working configuration. And they will do that after 10 minutes of not being able to connect to Extreme Cloud IQ after receiving new configuration. And that basically happens because the AP has two sets of configurations stored, or actually three: startup, running, and rollback. And rollback configuration on the device will always be last known working configuration, and last known working configuration means last configuration when the AP was still able to connect back to Extreme Cloud IQ. So, in the example where we pushed the wrong management VLAN down to the APs in Sydney, the access point would disconnect from Extreme Cloud IQ for 10 minutes. After those 10 minutes, they would figure out that they can no longer talk to Extreme Cloud IQ, and they would roll back the configuration to the previous known setting, so the previous VLANs. This gives you the time to change the mistake and to fix the mistake in the configuration and push it out again. And then when the correct management VLAN has been configured, the next time the access points will accept the configuration, no longer they will revoke the rollback. They will configure the correct VLAN, and then once they connect back to Extreme Cloud IQ, this configuration is written into the rollback configuration section, and this becomes the next rollback configuration because this is now the new configuration that's still able to talk to Extreme Cloud IQ. This can be a lifesaver in some cases, especially when you're sitting in one location and you're configuring tens or hundreds of remote locations, and you really don't have any feet on the ground to help you out with any misconfigurations or any problems there. So this enables a small number of administrators effectively managing very large and very diverse and distributed networks.